That's it. That's our topic today. Okay. This is our humidity sensor. Hello and welcome to this episode or to this training. This is a combined sensor of temperature and humidity. Okay. It's an intelligent sensor. It does have power supply. It does have ground and plus, and it has a data pin, and the data pin is done with information. So we need to talk to this sensor. Okay, there is again a library which is doing this. But before, let's do the hardware setup. This time we don't need the other hands. This time we will do this on our own. Okay. You do have the schematics in your script. This is how it should look like. You see, there is the sensor. It has 4 legs. Yeah. One is plus, one is minus, one is data. Data needs to be connected to the Arduino, and plus and minus are connected to 5 volts and ground. This here is a pull-up resistor. Okay, so the data line is pulled up and the sensor is actively pulling this to 0 if needed. Yeah? This is how you would build in a sensor, this sensor, if it is the bare sensor. Yeah? Now let's have again, oops. Now let's have again a look on our sensor. It's not it's not that easy, left, right, up or down. It's not the sensor itself. You see, the sensor itself, it really has 4 connectors. It really has 4 connectors, but there's a little PCB board, printed circuit board, PCB means, and there are only 3 legs. Yeah? And here we do have already this pull-up resistor is already built in. Yeah? So the hardware setup is pretty easy. Yeah? The hardware setup is just connect plus, connect minus, connect the Arduino board. Yeah? It's also breadboard friendly. I will just plug it in here. Tack. Okay. I'll do it this way because then you see it better from your side. So we need minus, ground. We need plus, 5 volts. Okay. We need the same things on the sensor. We need plus. And now where is plus? Yeah. Let's have a short look in the script. You do have the connections. So the PCB pin 1 is data. So this one is data. Yeah. Then 2 is VCC, so the ground, the plus. So I'll connect plus here in the middle. And then there is ground. Yeah. So we'll connect also ground. That's the other one here. This one I will connect to ground. Yeah. And here we do have data line from data to pin number 2. I choose. Okay. This is how it's connected. Okay. Here you see the difference. Pin PCB, pin sensor. Okay. The pin sensors you see in the data sheet. This is why I mentioned them here. So I will plug in now. Plugged in. Anything is getting hot? No. Looks good, looks good. Okay. So the hardware setup, as you see it here, is very übersichtlich. Yeah. Übersichtlich. What means übersichtlich? It's easy. Yeah. It's not too complicated. Okay, so let's communicate with the sensor. Communication with the sensor is done by the help of a library. Yeah, we are using the DHT library from Adafruit. Okay, so we are using these tools, manage library, and then we choose, once it is ready, DHT. Okay, we get a number of possible things, yeah? And I want to use this one, yeah? And here we see this is not installed, the Adafruit library. Where is it? Here, this one. So I press install now, yeah, and it said, okay, there are the dependencies. We also need the unified sensor library from Adafruit. Do you want to install these missing dependencies? Yeah, yes, I want to install all. And it's downloading, installing the libraries, and that's it. Suddenly it's written here install. So you see it's pretty fast. Okay, now we can talk to this sensor. This is what the library promised. Okay, so we include save, of course, save as, yeah. Proper name. Always stick to the naming convention. It helps. DHT11 sensor. That's the sensor name, by the way. DHT11. Okay, so we include the library we just installed. Now we include it. It's called dht.h. Yeah. And now we define DHT pin should be pin number 2. Yeah. And we define DHT type, and this is now nowhere written. This is DHT11. Okay. There's not only an 11, there's also a 22, I think. Yeah. DHT11. It's our type. And we're defining the object, the variable, the object of the type DHT, and I call it sensor, yeah, and it's available on the DHT pin, and it's a DHT type. Actually, this is stupid. Yeah, I will just write it here, DHT11. I think this is a definer for define is not really too meaningful. Okay, DHT pin 2, we connected to 2 here, passed sound. Okay, should be alright. I want to write what I read on the serial monitor, so I do serial begin, serial print line, and say print line serial, yeah, measurement started. Measurement started. Okay. And then DHT begin. That's the method. Sensors begin, of course. Sensor dot begin. That's the method to initialize the communication with the sensor. Okay. what we want to do is we want to read the humidity. Yeah? So I will define a type called floating point. Okay. What does it mean? Floating point. Floating point is a floating point variable. So it's some with a dot, yeah, comma word. Yeah. Takes 4 bytes, and we are getting from our sensor, we are getting this information by the floating point. Yeah. So we're getting the humidity by calling sensor dot and read humidity. Yeah. These things you have simply to know about the library. Okay, these things you have to know about the library, which methods there are inside. Okay. Read humidity. How do you know it? Yeah? If you do not know this library, yeah, you could open the Explorer, okay, and then navigate to your documents, and under Arduino and libraries, you're finding the libraries. Yeah? And there is this DHT sensor library, and there is a keywords. You could open the keywords. Yeah? Then you see which keywords there are. Usually there are already something meaningful. Yeah? So there is begin, read temperature, convert Celsius to Fahrenheit, convert Fahrenheit to Celsius, compute heat index, read humidity, read. Yeah. If we are not already satisfied, yeah, we can open, for instance, this dht.h. Yeah, this is the header file. This is exactly the file we are including here. Okay, this is exactly the file we're including here. So we can open this dht.h. I will open it with the editor. Yeah. And they are usually, there you see, okay, there's this DHT11, 12, 22, 21. There is this defined. This is why we can use this simply here. So this is defined inside the, can I zoom? Yes. This is here defined inside the H file. Okay. Here you can see the class definition. Yeah. So maybe you can read something out there. There are sometimes comments. Yeah. So this, if you're not familiar with a class, you can either use the description if you find it somewhere, yeah, or look even in the code. If it's written in the code, it should be working. Okay, that's it. You can also open the README, yeah, with the editor. There is not too much inside, yeah, usually. Yeah, so this is if you're not familiar with the library, yeah, you could look inside. Just a little help for you. But right now you are in a course, I tell it to you. Okay, so next value, we want to read the temperature. Temp, yeah, and it was sensor dot read temperature. Okay, reading the temperature, and then we could even use Fahrenheit. Right? True. Yeah. This now means we are reading Fahrenheit. Okay. So let's print it out. Yeah. Serial dot print. Yeah. Temperature. Print out temp. Then we write Celsius, and then we will immediately also calculate it in Fahrenheit. Yeah. And then we have the humidity, humid, U, %. This one I make a print line because then I want to have it in the next line. Okay, so let's download, upload again. You know what I mean. Bring it to the okay, we see it has 25.6 degrees and the humidity is around 60%. If I cover now, then we should see it's getting hotter. 25.8. Yeah. Humidity is also rising. Looks good. Yeah. So I have a heating tent under my 25.9 humidity. Humidity is rising, and if I open again now, the humidity should drop. Yeah. Humidity is a little bit. This sensor here is very cheap and not that accurate. Yeah. There are other DHTs out there. They do a much better job. Yeah. 26.1 degree. You see, it's riding very fast. What is if I disconnect here? Yeah, disconnect now, and then we get none value. Yeah, what does it mean? Not a number. This means none, not a number. So our floating point value has now the value none, not a number. This is indicating a wire break. I have disconnected. Yeah, if I reconnect, whoopsie. To use the right hole, then it automatically starts again. So the library seems to do its trick. Yeah? This is working pretty well. Yeah? However, I want it to be slower. Yeah? And I want to have it a little bit more. I don't want to print out none. Yeah? So I'm using if, yeah? And there is a function isnan. Yeah? Is it not a number? Yeah. Humidity. Yeah. Then I want to print out hello read error. Yeah. Or this is an or. Yeah. These two lines is none temp. So I could not read humidity or I could not read temperature. I don't care. I could not read something. Is none Fahrenheit. So if one of these things is not a none, yeah, I will simply write serial.println print line. Yeah, failed reading data from DHT sensor. Okay. And then I write return. What does this mean? Return means I stop the current function. So I stop the loop. I read it. If I have read it and I notice it's not a number, then I immediately stop it. Yeah? and everything which comes below is not happening. Okay, so let's upload this, try this. This looks pretty much like before. Yeah. If I now disconnect, pick, failed reading data from DHT sensor. It's a much smoother way dealing with error messages than just write wrong number. Yeah. For me it's a little bit too fast, so here I would just say I use a delay of, let's say, 1000. I only print out once in a second. Okay, much slower. Disconnect. Failed reading from DHT. Failed. There's missing an E. Failed reading from DHT. Okay. Okay, so sometimes you do have also the possibility, or I'm not sure, you have the temperature and you have the field temperature. Yeah, so if the humidity is high, it's feeling hotter. Yeah, so there would be also the possibility to calculate this. So I define a float value and say it's the heat in degrees Celsius, and I can, the sensor is giving me compute heat index. Yeah. It's calculating this for me. I can ask the sensor. Isn't it nice? Yeah. So it all needs, I give him the temperature. I ask the library. Actually, I ask the library. Okay. The library is covering this. I give the humidity, and I tell it's not in degree Fahrenheit. I tell it's in degrees Celsius, and I do the same for the Fahrenheit. Yeah? Then I will not only print out the temperature, I will also print out the heat. Yeah? And here I'm using heat. Okay, let's try this. Upload. Looking good. Yeah. So there is indeed another value. Ooh, 29. Of course. It's 78 degree Fahrenheit and I feel only 27. So it's pretty hot and I feel below freezing. This is wrong, of course, because why? Here I of course has to use the Fahren, and I have to remove this one. Yeah. Upload. Should look much better now. Yes, I feel 80 now. Okay. Disconnect. Failed reading data from DHT sensor. Working. Reconnect. Working also again. Yes, so that's it. Yeah, that's how we covered pretty much every function of this library. Just for your information, this is how to read data out of this DHT sensor. Yeah? And now your task is to make a little bit of weather station. Yeah? Print out the humidity and the temperature. For me it's fine if you only do in degrees Celsius, that's okay. on the LCD panel. Last time we had the LCD panel. This time I want you to print out these meaningful values of temperature and humidity. Okay, then you have already a weather station built up on our breadboard. If you really wanted to have it sophisticated, you can also introduce a button where you can switch between degree Celsius and degree Fahrenheit. This would be then an extra. This is how it should look like. Temperature, humidity displayed, live data. If I do disconnect the sensor, it should be written that it is disconnected and not just written not a number. If I reconnect, the current value should be here. So that's what you should try. And if you really want to know it, then make a button where you press, and then you can switch to Fahrenheit. And also here, if you disconnect, it should display that there is no valid value. Again, button press, switch back to degree Celsius. Okay? So, this is the goal. This means now we know how to make a weather station for ourselves. And now we know why they are not that expensive anymore. Okay. Next time we're going to make some noise. So this next time we are going to make some. We are using the buzzers. There's active buzzer, inactive buzzer. This is topic of next time. So we will make some noise there. For this time, thank you very much for listening. Goodbye.